Thank you. So indeed, we are the translator for the app 1 and app 2. And during the project, a nice video was made about these use cases. So I thought it was an excellent moment to show them as an introduction. If I can, do you want to do, or, okay. If we can find the play button, 1 second. There we go.
Procter & Gamble markets consumer products in more than 180 countries worldwide. Innovation has always been central to every area of our business. One example is aerial pods, put on the market in 2012. The soluble unit dose has since turned into a fast-growing laundry segment. To continually improve the design, performance and sustainability of these products, we've used groundbreaking tools. We're now pushing these technologies even further in partnership with OntoTrans. Leveraging its so-called ontology-driven open translation environment, the EU-funded project is developing smart apps that guide materials producers and product manufacturers. A new way of representing information, ontologies maximize the power of AI, data mining and information sharing. Procter & Gamble's Brussels Innovation Centre is participating in 2 connected use cases. The first accelerates the development of pod formulations. OTE connects internal and external data sources with modeling applications. This allows us to predict the characteristics of new formulations and select the most promising to progress to market. But what if we could predict how successful they would be? This is the aim of the second case. Coupled with machine learning, OTE improves our ability to mine and analyze historical sales data to better understand and predict market dynamics across multiple countries. These 2 cases have shown how an OTE-based approach will be a game changer for Procter & Gamble. It will enable us to design products faster and better, to more quickly evaluate new technologies and their consumer benefits, and to rapidly assess market dynamics and initiative success.
Okay, there we go. So as the movie already indicated, so there's 2 use cases. The app 1 is actually, in chronologically, would come at the end, but it is about predicting how a product will do in the market. So we're trying to see, like, okay, how many sales will we have based on the parameters of a product? And app 2 will be actually designing a product based on the formulation and so on. I will first go into app 1. So we have quite a bit of information available of all the products. I think I can immediately go to the next. So in this case, okay, we have the pots. These are the to put in the washing machine, but then they're packaged, and the package can also have a big influence on how it performs in the market, how flashy all the things are designed can have a big influence on how it's sold and so on. And so from this packaging, we also have some information, the size, as some people buy these pots in per 3, some buy them per 100. And then we also have something about the product launch. So how it was commercialized, in which country, which retailer, how is the presence on the shelf. And this is called numerical distribution. So the more a product is on a shelf, the more we hope to sell from it. So from this use case, an EMO-compliant ontology was designed. And as you can see, there's quite some things that I just described that come back in the ontology. Let's see if this fancy thing works. Maybe. No, sorry. Yes. So as you can see, we mapped all the aspects of this case back to the ontologies. And we have quite some properties that are also defined, like the country, the retailer, also the price of the product and the sales volume. But there's also some secondary things like, okay, what was the perfume used and the distribution and so on. So where does all this data come from? So this is actually data that P&G purchases through external vendors. So they look at the market and they look week by week how many of which products was sold. And that feeds back into the P&G database where it's maintained on a weekly basis. And this data we can then use. So what did we do? So we created machine learning models that will use some of these properties for each of the products, like the country, the numerical distribution, and the price. Build machine learning models of those, and those machine learning models will predict the sales volume. We did this for 3 European markets, Germany, France, and the UK, because each market will have different brands that are more common, and yeah, brands can totally perform different in every market, obviously. Yeah. At the end, we also want to evaluate our models, and that's what the next slide is about. So within the OntoTrans system, you can actually select a certain range for which of the data for which you train the models. And then in the models, you will see that there's quite some outlier products that don't fit the models. You want to look at them, you want to visualize them, and so on. Like, for example, here you have some products in certain week that really don't fit the predictions. This could be just because the models cannot capture certain things, or for example, because we did a promotion and the products were sold much more than we expected, and so on. Once we have this modeling pipeline in place, we also created an interface for this. So as you can see on the left, this is actually, one second. So on the left, you can see in this interface, you can actually define how you will train the models. So you can either say, yeah, I want to model a certain product. That's the GTIN, that's the unique identifier of a product. Or you can say, no, I just want to model all the products from France, from the brand Ariel, that have a certain number of jobs in the package. You can also give a reference period, and for that, you then can say, please train me the models. This training will be done quite quickly, a few minutes usually. And then as a result, we can actually say, okay, if we now have a new product that is similar to the query that we did, how will that product perform if we change the numerical distribution and the price? So that is what you see, I think, on the right, if I can show it. So the numerical distribution, if I already told you, that's about how often it is shown in the shop. So the more shops that have it, you hopefully have more sales. But of course, if you put a bad product in a shop too often, yeah, then it will eat away profits from your other products as well. So it is a tight distribution. And as you see, some products are only available maybe in 10% of the shops. Some products are in all the shops. And we also have then the price. And there we can really play like, okay, what happens if we put this product in the market? How many shops do we put it in? What will be the price? And we can really predict the sales performance. If you look at it, okay, how does it integrate with the whole OntoTrans system? So we made this diagram for that. So in the beginning, we as Translator, we could, for example, use the ESS, as Fajar explained at the beginning, to find something more about the product, the GTIN, and so on. What are the properties that are available? Once we know it, we can use in the wizards, we can start training, which will go to the OT APIs, and then eventually end up back behind our firewall, where like a worker will be running the actual models and training the models. So because of the data we cannot be shared, this part happens behind the firewall. Once this is ready, the metadata will basically go back into the OTA system and can then be accessed using the wizards and the ESS. Same thing will happen for the model evaluation, so I will not go into it deeply, but exactly the same procedure is happening. And then after all of this is done, you can actually go into the ESS and also see, for example, how a model training happened, which were the queries that were part of that model training. So it's all connected in a way. See next. So this was application 1. That's about, okay, predicting the price performance in the market. For application 2, where here we're actually trying to predict how a product will perform based on its formulation. So this is a bit more sensitive. So we will not go into deep details about this business case. But the general goal is, okay, given the formulation, how well will it perform? And how well will it be liked by users in the market? And the eventual goal, when we started at the beginning, was to have like a 5x increase in speed in the product development cycle of a new product. So these products are pouches. They have compartments. Each compartment can contain a different product, a different formulation. And of course, we also have the film that needs to be biodegradable and so on and so on. So there's quite a bit of parameters involved here. So for this, the data sources that were used are actually the private data from P&G databases. So they will have all their formulations, how they perform. For example, they will be tested a formulation, how it performs on a stain of a certain type, but also how stable is it. That's important for shelf life. You don't want the product to go bad if it is a few months on the shelf. Also on safety, sustainability, costs is obviously a big factor. And all of this is basically contained in the data and can be used to create models from. So that is the data source. What we then try to do, actually using this data, we try to predict the outputs of those formulations. Like, for example, how well does it perform? How sustainable is it? And how likely is it that the customer will actually buy this product? Once we have a model that works well like that, we can actually create a million virtual models, so to say, select them based and pick the top performing ones and actually try to bring those in the market instead of having to guess how well a product will perform. So that was a short introduction about this case. If we now go into the advantages that we brought on by OntoTrans, so one of the important things is just a description of the process. As you can see, it's quite complicated how all of this works. It's complicated to involve as a translator to understand how it works for the customer. It's complicated just to see how the production process and so on. And this makes it really easy to get a full description of the process and in the industrial case. By having this all documented well and ontologized, it's also easier to apply it to other cases. We can, for example, okay, now we're looking at the pouches for the washing machines, but maybe we can also use it for the dishwashers and so on, because the process will be quite similar. What it also did is make the modeling process much easier. We have like a log of everything that happens, all the transformation steps that need to happen to get the models done. So in that way, it's easier to see where a model comes from and how it was created. And for us, it's also the optimal solution to put the customer central. So basically now we will have a whole process from the formulation, how the customer will like it, till how the customer will buy it. So it's much easier to actually use this in practice and put the consumer as in the central place. If we look at the results of the business case, so we estimate that the whole case, there is indeed a 5x acceleration because we can create new formulations much more quickly. But of course, it's not only OntoTrans, it's the whole case combined. And with that, we're at the end of my talk.